Picture this. You ask your class, why do we wear coats in the winter? Half the hands go up and someone says, because coats make heat. Naturally, being the amazing teacher you are, you correct them. They all nod, but 5 minutes later, they're saying the same thing. Now that's not because they're not listening. No. It's because the demo we're using teaches the wrong model. In the next few minutes, I'm gonna show you one small setup change that's gonna prevent this misconception. Plus, a simple classroom experiment you can run today with materials that you already have. Here's what usually happens in lessons. We mention body heat, and then at some point we introduce a coat. I should have kept the coat on for this. We say the coat keeps the heat in, but what students actually observe is feeling a little bit cold, put the coat on, now I'm warmer. Thus, coats make heat. The warmth appears after the coat goes on, so this is kind of what they assume where the heat comes from. And the problem isn't our explanation, it's because pupils never see heat leaving. I mean, no one really sees heat leaving. We never see heat leaving. We can feel its effects and we can see what's happening on the thermometer, and this is exactly why kids get confused. So they basically invent a rule. If something's warm, it must be making heat. They don't misunderstand codes. They misunderstand our bodies losing heat. And more specifically, they misunderstand heat transfer because we never told them. So how do we fix this? How do we teach them all about insulation? Well, it's about the order, not the explanation. So before we start explaining insulation and wrapping things up and cooling and all that kind of stuff, what we must first prove is when we wrap something, it doesn't warm up. Break this idea before it ever forms. We don't start with hot water, we don't start with coats. No. What we do is we start with 2 identical beakers filled with water that's been left out for hours. This water is super boring. Same air, room temperature, identical. This is exactly where we start. Now what I want you to do is wrap one up with some insulation. This is super simple, some colored card and some cotton wool on the inside. Make sure you also cover the top. Then what I want you to tell the kids is to keep an eye out for the temperatures. Tell them, guys, I need you to call out all the readings. I'll write everything on the board, don't you worry, but I want you to call out all the readings for both of the mugs. We're gonna see if this one increases in temperature. And what the students should recognize is nothing changes. And I mean, of course nothing changes, but the students don't know that yet. And this demo does exactly that. The insulation alone doesn't heat anything up. And they can try. And all they're gonna do is read the same temperature out to you. Sir, it's 19 degrees. Sir, it's not changed, it's 19 degrees. And they're just gonna repeat the same thing out. And they will understand, okay, this clearly isn't doing anything. Now we can bring out the hot water. So what we do is simply bring out 2 mugs and we do the same thing again. We wrap one, not the other. And of course, you know where this is going. This is going to drastically reduce in temperature. This one, it's still going to reduce in temperature, but not as quickly because it's insulated. And this is the moment the kids will understand exactly what insulation's doing. The wrap didn't add heat. We already proved that. All it did was change how fast the heat was escaping. And now you can introduce a term. This, boys and girls, is called insulation. And insulation is something that slows heat escaping. Well done. So up until now, we've kind of been in classroom mode, measuring, testing, as kind of figuring out what happens. But I want us to zoom out a little bit and start thinking about engineering. Because once kids start understanding the true meaning of insulation and kind of where it all applies, they start understanding how the world actually works. And basically what we all want, for them to stop just memorizing things. So in the real world, heat doesn't have a good or bad. Sometimes we just want to get rid of it. Sometimes we want to keep it in. Confusing the two is where systems fail. Take computers. They don't have a cold problem. They're basically trying to get rid of heat. You start wrapping a computer around in insulation, it's not going to last 5 minutes. So data centers, you know, the ones that we hear about, Google and AI and all that kind of stuff, they churn out so much heat. I mean, half the electricity bill is just keeping those things cool. The aim here is just getting rid of that heat as quickly as possible. Otherwise, those computers, they're just not gonna last. So it's the same physics, just a different goal. Now let's think about houses here in the UK. In the UK, it's kind of a cold climate. I mean, the majority of the year is quite cold. So our houses are insulated. Our roofs, our walls, all insulated. So in the winter, we're not losing all of that heat. Now the problem comes is when we get that occasional heat wave, these houses roast up. It is so hot in these houses because of all that insulation that's in between the walls and the roof. In the winter, it's brilliant at stopping the heat from escaping. In the summer, when it's really hot, not so much. And that's why we start to overheat a little bit in our houses in the UK. And here's where it gets really interesting. In London, there's a famous line called the Central Line. It's deep, deep underground, buried in rock and clay. Trains, they generate a lot of heat. Passengers, they generate a lot of heat. Braking, that generates a lot of heat. So this train, deep underground, is producing an enormous amount of heat. The problem is, the ground all around it is insulating that train completely. Now these tunnels are so small, we can't even put an air conditioning unit on there. So what do the engineers do? Well, they don't know. The train is so well insulated that engineers haven't figured out a plan yet, and this is a problem that's happening today, tomorrow, and might carry on happening until we figure something out. So insulation isn't good or bad, it's a tool. Sometimes you try and keep the heat in, sometimes you try and keep the heat out, sometimes you're trying to figure out what to do. Central line, but it never adds heat. It only controls the rate heat moves. And once kids get that, they don't just understand codes, they recognize this idea everywhere. Houses, trains, tunnels, even inside their own bodies. And now we've moved far from just memorizing, we're understanding. And that's why this lesson matters so much. Once you fix that setup and the kids understand the true meaning of an insulator, they will really start to see how the world works. If you want more classroom ideas rebuilt around the world that we live in, hit subscribe, more is coming.